Okay, so today we'll be working on the TapeEquilibrium problem from Codility. Initially, when I read over this, I actually got confused. I didn't quite understand the question, so I'll go into detail as to what they're asking. During an interview, it is very important that you ask clarifying questions, because the worst thing you can do is try to solve a question and you're solving the wrong question, not the one that the question asked, right? So by asking clarifying questions to the interview, you won't waste any time solving the wrong problem. Okay, so let me read the problem now. A non-empty array A consisting of n integers is given. Array A represents numbers on a tape. Any integer p such that 0 is less than p is less than n splits this tape into two empty parts. And it gives examples of potential splits. The difference between the two parts is the value of the first half minus the second half. In other words, it is the absolute difference between the sum of the first part and the sum of the second part. For example, consider an array A such that A of 0 is equal to 3, A of 1 is equal to 1, A of 2 is equal to 2, A of 3 is equal to 4, A of 4 is equal to 3, and we can split this tape into 4 places. P is equal to 1, the difference is 3 minus 10 is equal to 7. P is equal to 2, the difference is 4 minus 9 is equal to 5. P is equal to 3, the difference is 6 minus 7 is equal to 1. P is equal to 4, the difference is 10 minus 3 is equal to 7. Write a function that, given a non-empty array A of n integers, returns the minimum difference that can be achieved. For example, the function above, when fed this array A, should return 1, as explained above. Write an efficient algorithm. Okay, so if we look at the question, we're given an array, and it'll be in the following format shown in this diagram I made, which will have 3, 1, 2, 4, and 3. So basically it's like a long lottery ticket, and each lottery ticket has numbers associated with it, and you could tear apart that lottery ticket, right? However, you're basically tearing it at one spot, and the spots are labeled that you could tear at are labeled P, right? So P0, P1, P2, P3, and you could only make one rip. And in this case, the key to winning this lottery is to tear it at a place where the right side and left side are almost equal. So you want to minimize the difference. And by almost equal, I mean the numbers on the tickets of both sides, when added up, will have almost the same value. You want to minimize that difference, and that's a win. So that's the key to the game. So for example, if you got this lottery ticket, which is fed in as A is equal to 3, 1, 2, 4, 3, and you ripped it at P of 0, the left hand of the tear would have the value 3, and the right hand would have the value 10. Before it was torn, the total value of the total ticket, all combined, would be 13. I hope that's clear, and this diagram should sort of help you understand what they're actually asking. If not, feel free to ask comments. I'll also post a question in the comment box below. So let's start solving this problem. Okay, so we'll solve it in JavaScript. And let's see. So what are we going to do? 1. So let's break down the steps, because we already diagrammed what we're going to do. So how will we solve this from code perspective, right? 1. Iterate through the potential points where we can tear the tape. 2. At each tear, calculate the value of the tickets contained in the left portion of the tape and subtracted from the right portion of the tape. 3. Store the value if it is smaller than the previous. Then store the difference if it is smaller than the other values that have been stored. Alright, so we got that. So next what we're going to do is actually start coding for this. So our first variable that we'll declare is the min difference, and we'll set that to number.max value, right? So basically we're taking the maximum number, because any split that we make is going to be smaller than max number. So basically this min difference variable is going to store the minimum difference that it finds between the two portions of the tape that are torn. Next, what we need to do is find out the total value of the tape when it's untorn. Untorn tape value, right? We'll start off at 0, and now let's just create a loop. Let I equals 0, and now we're going to iterate through the array and get the value. We'll sum it up. So while I is less than a dot length, I plus plus, right? And then untorn tape value plus equals a of I. By doing this, we're basically getting the sum, or calculating the sum of the untorn tape. So now we have that, and that's what we're going to use in order to determine the values of the left and the right tapes, right? So now we're going to iterate through our tape again. So initially we're going to have a right sum, a left sum, which will equal to the min difference right off the bat, or not min difference. It's going to, the left sum initially will be the untorn tape value, right? Actually, that'll be 0 initially because we're starting off at the left side, and the right sum will be equal to untorn tape value, right? So what we're going to do with this next loop is calculate the value of the torn pieces of tape, right? And we're going to store the minimum difference that we find. Before optimizing it, usually what I like to do is brute force a problem in order to solve it, whichever way comes to mind, because a solution is better than no solution. And then afterwards, if that solution works, I'll look for a faster way to do it. So find the minimum difference between the torn tape portions. Let I equals 0, I is less than a dot length, I plus plus. All right. Okay. So what are we going to do here? We're going to start calculating our left sum and our right sum. So at all times, the left sum is going to be growing as we increment our I, right? Next, our right sum actually is going to be decrementing as we decrement our I. Furthermore, we don't want to go past the end of the tape because we're only going 4 portions, right? There are only 4 splits if we look at the diagram. So we want to start off at P0, P1, P2, and P3. However, if we look at the code right now, a.length is actually equal to 5. So in this condition, it's going to stop at 4 and start at 0, right? As we iterate through the loop. However, we need to stop at 3 because it's only going through 3 splits, right? There's only 4 splits available. So what does that mean? We have to go to a length minus 1, right? Now we have an if condition within our loop. So if math.abs of, so we're taking the absolute value of, actually we could even create another variable here, let diff equal, no, we don't need it. Let's create current diff. That'll be equal to this to start off with, the maximum number that it could be. So current diff is equal to the right sum minus the left, no, the left sum minus the right sum, right? Left sum minus right sum, and we take the absolute value of that. Okay, so if the min difference is greater than the current difference, what we do is we make the min difference, we set the min difference to the current difference, right? And then at the end of that, after going through the entire tape, we've found all the permutations, we can return the min difference. So alright, that is what is happening. Now let's make sure, what I like to do before I test things out, I like to test things out, but I like to use a console.log, right? To make sure that the values that I'm seeing are the correct values. So let's just print it out. Left sum plus, so by using a console.log in the loop, you can make sure the iterations in the loop are going as you expected. Because sometimes we rush things and it doesn't, and we'll miss small things. So let's run it. Okay, so as you can see, as we go through our loop, the actual left side and right sides of the tape are calculating correctly, and our answer is acceptable. Okay, so we have done that. We'll run it. It says our compilation is okay, and let's submit the task and see how we did. Okay, so Codility is now calculating our results, and we'll see if it passed the performance tests and the correctness tests, etc. Okay, we got 100, right? So yeah, that is the tape equilibrium time complexity problem on Codility. So I hope that helped. Until next time.